Assalamualaikum warahmatullahi wabarakatuh. Today our group will be presenting about exploring polymerization method for polyethylene production. What is polyethylene? Polyethylene, often abbreviated as PE, is a common durable plastic with the chemical formula C2H4. It's widely used for items like frozen food bag, bottle, serious lining and minimum. Plastic labeled with recycling code 2 and 4 are made of PE, which may have different crystalline structure. What is the significance of polyethylene? Polyethylene is widely used in packaging for items like plastic bag, film and bottle. Application extend to crate, trays, jug for meat or fruit juice and minimum. High density polyethylene (HDPE) is versatile, employed in toy, garbage container, ice tray and many more. Meanwhile, for low density polyethylene (LDPE) is known for flexibility and cost effectiveness, commonly used in squeeze bottle, garbage bag, lamination and minimum. Polyethylene serves as a good electrical insulator, making it suitable for cable jacking. What is bulk polymerization? Bulk polymerization is a solvent-free and simple method. It is commonly used for various polymers, including polyethylene production. However, managing the heat release in isothermic chain growth reaction can be challenging, necessitating efficient cooling coils. Sliding is also hindered by the high viscosity of high molecular weight polymer. This method is often used to produce polyethylene, a widely used thermoplastic categorized into high density polyethylene (HDPE) and low density polyethylene (LDPE), with HDPE being frequently produced product. Next is method and principle of bulk polymerization. First is initiation. Organic parasite or other compound are introduced into reaction vessel. Initiation break chemical bond in the ethylene monomer, creating free radical. Example like organic parasite decompose, forming this free radical. Free radical initiate polymerization by attacking ethylene molecule. The process break carbon-carbon double bond in the ethylene. Next step is propagation. During propagation, free radical from initiation react with ethylene molecule. Continuous polymer chain growth occur during the reaction. Ethylene monomer lose hydrogen atom in the process. The reaction generate few new radicals as ethylene react. The repetitive addition of ethylene monomer from the growing chain. The process create a polyethylene chain. The repeating unit in the polyethylene chain is C2C2. Last step is termination. Termination conclude polymer chain growth. Two free radicals combine, forming a stable molecule. One free radical abstract a hydrogen atom from another chain. This leads to the combination of the two chains. The process results in the release of new free radical. The growing polymer chain transfer to another molecule, terminate one chain and initiate another. Termination step influence the final property of polyethylene. The nature of termination process affect the structure and characteristic of resulting polymer. Let's talk about advantages and disadvantages of bulk polymerization. Advantages of bulk polymerization is high reaction rate, simplicity of process, high yield, and fewer separation steps. Meanwhile, for disadvantages, is molecular weight distribution control, energy intensive, heat removal challenge, limited control over morphology, polymer purity issue, and limited applicability to LDPE. What is the example of product and application bulk polymerization of PE? Bulk polymerization of polyethylene is commonly used in various industries to produce a range of products with different applications. As example, container and bottle, pipe and fitting, film sheeting, industrial drum and container, toy and supporting goods, crate, pellets, automotive part, geometry, rotational molding application, and household product. Bulk polymerization is commonly used for high density polyethylene (HDPE). Low density polyethylene (LDPE) is typically produced using high pressure free radical polymerization method. The charge of the polymerization method depends on the desired property of the final product and the specific requirement of the application.
For solution polymerization is a process where monomer dissolve in a solvent during the reaction. Polyethylene, a versatile polymer used in packaging and pipes, can be produced using various methods, including solution polymerization. Actually, there are so many to discuss, but I have to take the most important one. So the typical step for solution polymerization of ethylene include initiation, propagation, and termination. For initiation, the step leads to formation of free radicals which will react with dissolved ethylene monomers. For propagation, the polymerization continually extending polyethylene chains with uniform properties. For termination, polymerization was hard to control the molecular weight of polyethylene. Next, this is the principles and conditions of solution polymerization. The key principle and condition include of choice of solvents which should be able to dissolve monomers, high molecular weight to allow for the continuous growth of polymer chains, polymer purity so that it can contribute to the production of high purity polymers, and lastly, polymer recovery and purification where techniques such as precipitation or solvent evaporation are used for polymer recovery. For advantages and disadvantages of using solution polymerization for PE. The advantages is in the slide that you can see, which is control over molecular weight which can improve mechanical properties. The other is scale up potential which providing a pathway for efficient manufacturing. For disadvantages, it include the solvent handling and recovery which increase the complexity and costs, and the other is energy consumption is too much. Lastly, for examples and application, solution polymerization is commonly for large-scale production, where the example provided is a high-performance polyethylene product. For examples, biomedical appliances and electroactive polyethylene for electronic device, while solution polymerization is ideal for specialty polyethylene. Now, for emulsion polymerization make polymer by combining monomers in droplets in water. Water is the main part, and surfactant prevent droplets from coming together. It's great for making latex polymer, which are tiny polymer particles in water. The essential principles and factors involved in emulsion polymerization is in the following step. I have concluded and make it in polymerization mechanism. For initiation, initiators need to be water soluble and oil soluble to generate free radicals. For propagation, polymerization occurs within the monomer loaded micelles. Polymerization continues and the monomer droplets grow into the polymer chains. For termination, this involves the recombination of radical or the addition of termination agents. It's essential for controlling the molecular weight. Actually, emulsion polymerization is not usual for making polyethylene. On the other hand, it is using ethylene polymerization, primarily manufactured using two main processes, which is high pressure polymerization and low pressure polymerization. For high pressure polymerization, high pressure was used for ethylene molecules to react and form polyethylene chains. For low pressure polymerization, low pressure involves the use of catalysts to polymerize monomers at low pressure and temperature. This is the advantages and disadvantages of employing emulsion polymerization for PE. For advantages, it can produce good control over particle size and it also ease of handling. For disadvantages, the production often requires high temperatures and pressure. It also has limited applicability because emulsion polymerization is more commonly associated with the production of latex polymer. In summary, emulsion polymerization is not a common method for production of PE. However, advancement in polymerization technique may have occurred. For examples, production of latex paints, adhesive, and textile coatings.
I want to explain to you about suspension polymerization in polyethylene. First thing first, what is suspension polymerization? Suspension polymerization is a process used to produce polymer particles in the form of beads or microsphere. In this polymerization technique, monomers are dispersed in a liquid medium, typically water, with the help of stabilizing agent or surfactant to prevent the coalescing of polymer particles. The monomer droplets are suspended in the liquid medium and polymerization occurs within these droplets. Next, I want to explain about the process of suspension polymerization in polyethylene. The process is divided by two, which is HDPE and LDPE. Firstly, the HDPE. The initiation is the process of ethylene begins at high pressure, typically several thousand atmosphere, at high temperature using a radical initiator. Next, propagation. The ethylene monomer undergo chain propagation forming high molecule weight polyethylene chains. Next, the termination. Chain termination occurs and the polymerization is stopped. Next, the LDPE. The initiation is the catalyst, commonly Ziegler-Natta catalyst or metallocene catalyst, initiate the polymerization reaction at lower pressure and temperature compared to high pressure processes. Next, propagation. The catalyst facilitates the insertion of ethylene monomer into growing polymer chain. Next, the termination. The polymerization is terminated and the LDPE is obtained. Next, I want to explain to you about the advantages and disadvantages of suspension polymerization in polyethylene. The advantages is the heat removal and temperature control relatively easier. Next, the polymer obtained in a form that is convenient, easily to handle. Third, resulting polymer suspension or granulating may be directly usable. Next, the disadvantages. Firstly, need to maintain stability of droplet require continuous and minimum level of agitation. Second, possibility of polymer contamination by absorption of stabilizer on particle surface. Third, continuous operation of system difficult. Next, I want to give the example of product and application suspension polymerization of polyethylene. Suspension polymerization of polyethylene is commonly used in industries to produce PVC pipe. As example, polyvinyl chloride PVC beads. The application in PVC pipes. The PVC beads produced through suspension polymerization can be further processed into various forms, such as powder or pellets, and used in manufacturing of PVC pipes. PVC pipes are widely used in construction for water supply, drainage system, and underground conduct system. They are favored for their durability, corrosion resistance, and ease of installation.
Today, I would like to introduce to you guys about gas phase. First thing first, what is gas phase? Well, gas phase polymerization is one of the techniques which is used in the production of polymer, where the polymerization for monomer ethylene reaction takes place in the gaseous phase. As we know, polymer are large molecules composed of repeating units, which is called monomers. In gas phase polymerization, these monomers are polymerized with the presence of a catalyst and under specific condition in the gas phase, specifically in a reactor. Now, we are moving on to the process of high pressure polymerization, or we call it as HDPE. The initiation, the catalyst initiates the polymerization reaction by activating the monomers, which is ethylene, and facilitating their incorporation into the growing polymer change. Next is the propagation. These steps contributes the elongation of the polymer change and the formation of the final HDPE products. The fluidized bed reactor plays a crucial role in allowing the polymerization to occur in this continuous and controlled manner. And then we go into the termination, which is the gas phase polymerization refers to the mechanism by which the polymerization reaction is stopped and the polymer chains are brought to the end. Proper termination is crucial to control the molecular weight distribution and other properties of the high density of polyethylene in HDPE product. And then we are going into the low pressure polymerization, which is the LDPE for gas phase polymerization. For the initiation, as we know, the process begins with the initiation steps where the free radicals is generated on the surface of the catalyst or through the actions of separating initiator. Common initiators include organic peroxides or other compounds that can generate free radicals. And then we are moving on to the propagation. During the propagation step, the monomer molecules, ethylene in the case of LDPE, react with the free radical, forming a polymer chain. In gas polymerization, the monomer is typically in a gaseous state, and it adds to the growing polymer change on the surface of the catalyst. And then, moving on to the termination. The termination reactions occurs when two free radicals combine to form a stable molecule, stopping the growth of the polymer change. The termination steps is crucial for controlling the molecular weight and polydispersity of the polymer. Moving on to the advantage and disadvantages of the gas phase polymerization. For the advantages, we have the high purity and yield. The gas phase polymerization often results in high purity polymers because the process takes place in the gas phase, reducing the likelihood of impurities. Next one is the easy of scale up. The gas phase polymerization process are often more amenable to scale up than some other polymerization methods. Reactors can be designed to handle large production capacities. Next one is the reduced environmental impact. The gas phase process can be more environmentally friendly because they often eliminate the need for solvents or excessive byproducts associated with other polymerization methods. Next, we go to the disadvantages of gas phase polymerization. We have the limited monomer solubility. The solubility of monomers in the gas phase can limit the reaction rate and overall polymerization efficiency. This is particularly relevant to the monomers with low gas phase solubility. And then we have the polymer quality and properties. Achieving specific polymer properties such as molecular weight distribution and branching can be more challenging in gas phase process compared to solutions or slurry process. Next, we have the reactor fouling. The formation of polymer deposit on the reactor walls or fouling can occur, affecting heat transfer and requiring periodic reactor cleaning. Lastly, we are going to the examples of products and application gas phase polymerization of polyethylene. We have the film and packaging, containers and bolters, and also pipes and pipe fitting. This example highlights the versatility of HDPE produced through gas phase polymerization and its widespread use in different industries. The specific properties of HDPE, such as its strength, chemical resistance, and flexibility, contributes to its suitability for a broad range of application.
I want to explain to you about comparative analysis based on 5-method polymerization. Firstly, for the scale production in factory, bulk and gas phase polymerization are suitable for the large scale production, while immersion and suspension polymerization are versatile for both small and large scale. Second, while immersion and suspension polymerization could contain contaminant from stabilizer or surfactant, bulk and solution polymerization provide great purity. Third, excellent control over particle size is a feature of immersion and suspension polymerization, which make them appropriate for some application. Fourth, for the energy consumption, normally gas phase polymerization use less energy than other techniques. Fifth, for the process complexity, while immersion and suspension polymerization require extra stages for stabilization and dispersion, but polymerization is comparatively straightforward.